Welcome to science class. Today we will be investigating the role of climate and how it shapes ecosystems. Nothing is more impactful on life than climate. Producers support all of the organisms in an ecosystem with the energy and building blocks they need. Producers depend directly on the climate. Limits in sunlight, moisture, or warmth will limit the growth of producers and therefore lessen the biodiversity of an ecosystem. Now, weather and climate are not at all the same. In my home state of South Dakota, we have plenty of days throughout the summer months where temperatures are equally as high as they are in California, where I live now. But I'm now 1,000 kilometers closer to the equator than I was back home. For 3 months out of the year, my home area experiences average highs below freezing, whereas the lowest average temperatures here are still 55 degrees Fahrenheit. So the weather varies greatly. Despite that, though, you find a higher density of producers throughout much of South Dakota than in the particular part of California where I live, the San Joaquin Valley. There are 58 days with rain totaling about 61 centimeters in my home area, and only 26 days here totaling about 28 centimeters. But these things can fluctuate greatly. In recent years, my current town may see a year go by with almost no precipitation at all, whereas just last winter in Watertown, South Dakota, where I lived, we got over 220 centimeters of snow. Climate is complicated. There are a wide number of factors at play, but understanding those factors is an integral part of ecology. Let's get started. Although I have no doubt you're smart enough to know this, we still haven't actually distinguished the difference between weather and climate. Weather simply describes the current condition of Earth's atmosphere in a specific place. Weather changes by the season, month, day, even minute. South Dakota actually holds 2 world records for temperature fluctuations. In 1943 in Spearfish, the temperature rose from negative 20 degrees Celsius to 7 degrees in only 2 minutes. This rapid warmth broke windows and caused tree trunks to burst open as the frozen sap within them rapidly expanded. The opposite happened as well. In 1911, in Rapid City, the temperature plummeted over 27 degrees Celsius in 5 minutes. Now, while these are extremes, we have all experienced the unpredictability of weather. Rain or hail comes out of nowhere. Strong wind gusts arrive without warning. That is the chaotic nature of weather. Even though there can be extreme fluctuations in weather, if you average out the conditions day by day, you will get a fairly steady trend. This is what climate is. People who don't understand the difference between the two will say idiotic things like, "It's supposed to be 25 below zero this weekend, therefore global warming isn't real." A U.S. senator once brought a snowball into the Senate in order to prove that global warming isn't real. Not only is this extremely stupid and ignorant, but it's also wildly arrogant. But it is something that all of us are guilty of in one way or another. We tend to look at the world through the lens of our own experience. But one person or one city or one cold day represents a puny, tiny, pathetic sample size of what's really out there. The tallest person alive is Sultan Kosin, and he's from Turkey. It would clearly be ridiculous to conclude, therefore, that people from Turkey are the tallest people in the world. You have to actually go out in the world and take measurements. It turns out that Swedish men are 7.5 centimeters taller on average than Turkish men. Okay, I know that I'm not talking about climate right now, but this is a science class, and you need to also learn how to think scientifically, or at least put a little effort into it, because people who don't know how to do that misrepresent science, and then we end up being wrong. Or they do understand it, but they lie to you. And this is particularly done with climate, although the facts have beaten most of this into the ground in recent years. Here's a graph of global average temperature anomalies. basically how much the temperature fluctuated above or below the average temperature. You can see that in 1998, there was a record high anomaly which lasted for a few years that was caused by an El Nino. Opponents of policies to reduce carbon emissions used this to say there has been no warming since 1998, or warming did not increase. And they'll show you the data with only a few years on it to make the graph look like it's saying what they want it to say. That is data manipulation, or just flat out lying. The years 2005, 2010, 15, 16, 17, 18, and so far 2019 have all been warmer than 98. Plus, if you look at the entire line of data, it's obvious that it's trending upward. Even if we only go from 98 to present, which is stupid to do, but we'll just play their game by their rules and win anyways, look at the anomalies for low temperatures. Those are trending upward, even when the high temperature anomalies did not surpass 1998's high. Sometimes, yes, you can have an opinion on data because that data may not tell the entire story. But you can't have an opinion on this. We can actually measure temperatures. We do measure temperatures. Every country on Earth that has a scientific infrastructure does this independently. There is no conspiracy. It's getting warmer. Okay, I promise we're going to focus on how climate influences the biosphere from now on. The dominant factors that shape an area's weather and climate are solar radiation, geography, altitude, and latitude. We're going to cover each of these in detail. The reason we have seasons on the planet is twofold. First, because the planet is a sphere, its surface is bathed in solar radiation at varying levels of intensity. That alone would not cause seasons, but because the Earth is also tilted, the temperate zones fluctuate between direct and indirect solar radiation, which leads to the fluctuations in the amount of heating of the atmosphere and the oceans. To illustrate this, compare the temperate zones on the planet when it is winter in one hemisphere and summer in the other hemisphere. You can see that one band of solar radiation is concentrated over a certain area, whereas the exact same amount of solar radiation is spread over a much larger area at the corresponding latitude in the other hemisphere. In New York City, the sun is at an angle of about 73 degrees on the summer solstice, the longest day of the year, and the day when Earth's North Pole is pointing directly toward the sun. Meanwhile, on the winter solstice, the sun is at a very shallow 26-degree angle in the sky. If you spread heat over a larger area, it doesn't heat up as much. Simple. There's more to it than simply receiving light from the sun. Earth's atmosphere plays a crucial role in maintaining steady temperatures on Earth. Now, the difference at any one time between the hottest and the coldest place on Earth can be as much as 141 degrees Celsius. But that's not a logical comparison. Instead, compare the difference between day and night in the same location. Deserts have the greatest fluctuations, but they're pretty slight, only around 31 degrees Celsius. The moon, which is the same distance from the sun as Earth, sees temperatures on its lit surface of 127 degrees Celsius, and lows on its dark side of negative 173 degrees Celsius. Without an atmosphere, thermal energy simply radiates off into space, and so no warmth is retained. And without clouds, atmosphere, ozone, and other things to reflect sunlight, the surface is blasted with the full force of the sun. The balance in the way that Earth absorbs some of the sun's radiation and does not allow all of it to escape is our greenhouse effect. The greenhouse effect is essential to weather and life on Earth. Greenhouse gases, like these, trap radiation. We're not going to get into the physics of how that works, but only a select few gases do this. Carbon dioxide is the most influential because it is the highest concentrated in our atmosphere. Methane is roughly 30 times more powerful of a greenhouse gas than carbon dioxide, but there is very little of it in the atmosphere. Worryingly, though, methane levels are dramatically rising because of cattle and the thawing of permafrost in the polar regions, which is causing long dead but previously frozen organic matter to decay, releasing methane. Water is actually the most powerful greenhouse gas and contributes the most to the warming effect. But water vapor fluctuates with temperature because it comes from water evaporating, whereas carbon dioxide levels don't rise and fall during the day or season. That pretty much covers solar radiation and latitude, but those factors alone never tell the whole story. Altitude also plays a huge role. The tallest peak in the world, Mount Everest, is perpetually covered with snow. But only about 50 kilometers from Everest, there is a rainforest. Everest is just a tiny bit outside of the Tropic of Cancer. Altitude affects climate because the density of Earth's atmosphere dramatically declines with elevation. Only 3,000 meters above sea level, the air is only 75% the density it is at sea level. During the day, solar radiation heats up the land, but at night, that heat radiates into the atmosphere. A more dense atmosphere slows down that loss of heat significantly. I camped in Bryce Canyon, Utah one day a couple years ago, and the daytime temperatures were hitting just about 32 degrees Celsius. But when I woke up in my tent at about 6 in the morning, I was shocked to discover that the ambient air temperature was only 2 degrees Celsius. Bryce Canyon is over 2,700 meters above sea level, and I did not take this into account when I failed to pack anything warm. The hottest place in the world, Death Valley, actually sits well below sea level. But it's not just the altitude. An area's geography really reveals its climate patterns and helps make sense of the sometimes very sharp boundaries between two completely different climates. When I say geography, I'm really talking about your proximity to certain geographic features like a mountain chain or the ocean. Mountain ranges drastically change the climate of the areas surrounding them. Many areas along the tropical region of Asia experience monsoon seasons. These bring enormous quantities of rainfall. When you view Asia from space, you are struck by the dramatic contrast between the tropical green regions all along the southeast with the brown, seemingly lifeless deserts of Tibet and Mongolia. The only reason this region looks this way is because of the Himalayan mountains. Moisture and warmth from the Indian Ocean moves inland, but it cannot pass over the peaks of the Himalayas. The moisture condenses and falls as rain and snow, which then drains through a series of rivers into the Bay of Bengal. Without these mountains, huge spans of China would be green and extremely productive. It's pretty much just bad luck that they aren't. This is what's known as a rain shadow, the side of a mountain range that is cut off from regular precipitation. Death Valley in California is cut off by 3 different mountain ranges. When I moved to California, I was struck by how suddenly the environment changed. I literally drove around one hill and the whole scenery shifted from sand, dust, and naked rock features. It's the Mojave Desert after all. Then all of a sudden, there were trees and farms and grasses growing. The Central Valley of California is extremely productive thanks to the weather that allows growing all year round. California raked in almost $45 billion in agriculture in 2015. More than any other state. But a huge amount of that productivity relies on cheating. See, earlier I told you it only rains about 28 centimeters a year. If you drive around the town I live in, you will see field after field of orchard farms growing lemons, oranges, and other fruits. These trees cannot live here normally. Here is an orchard that is no longer maintained, and you can see that it is quite dead. This entire area is hydrologically engineered. The St. Johns River has its source high up in the Sierra Nevada mountains. You can see these mountains from my backyard, and the river is less than 100 meters from my house as well. The mountains are obscured almost every single day by clouds, also air pollution, but the constant moisture funnels down the mountains into the valleys and creates this river. Right now it's July and this river flows very strong, but soon it will run completely dry. There are irrigation ditches dug all along the river, which divert the water to farms where it is used to grow these crops. These irrigation ditches even run through the town. Finally, I just want to touch on the role of oceans. If you talk to a climate scientist, they will tell you that oceans actually dictate the climate, whereas the atmosphere dictates the weather. I'm going to give you the simple version of this. Water has a very high specific heat, meaning it can store and release more energy than air can, much more. Living near the ocean has massive influence over your climate, but it also matters which part of the ocean you live by. We'll illustrate this with some examples. When you picture the UK, you probably don't imagine bitter cold winters and piles of snow. Well, that's because none of those things happen there. If you look at the average temperatures for London, there isn't a single month where the average low is below freezing. Now, the reason that is really weird, at least on the surface of it, is because London is as far away from the equator as Edmonton, Alberta, where 7 months out of the year, the average low is below freezing. This is because the UK is an island and receives warm water from the Gulf Stream current, which releases heat into the atmosphere, warming it. But this is also just an accident of geography. If you go directly west and touch the coast of Canada, also on the Atlantic Ocean, the same distance from the equator as the UK in St. John's, Quebec, the temperatures are much, much colder in winter. Ocean currents circulate according to Earth's rotation. You can see this clearly visualized if you look at a world map showing ocean surface temperatures. Being near the water also has the effect of stabilizing temperatures, keeping the fluctuations down. Look at the average high and low temperatures for Seattle, Washington. There's barely any difference. However, in New York City, on the opposite coast, you can see the highs and lows are much greater. This is because New York City lies on a coast where the winds typically blow out into the ocean, pushing away that stabilizing heat the oceans bring, while the winds are exactly the opposite in Seattle. Oh, and it doesn't actually rain as much as you think in Seattle. It actually rains more in New York City in terms of total precipitation. I could easily go on, but we will stop there. I know that was a lot of information, but the climate is very complicated. But with the right kind of technology and with an open mind, nothing has to be outside of our grasp of knowledge. Next time, we are going to take a look at how matter is recycled in the biosphere between the air, soil, water, and living things. Thanks for watching.